Hi students, നമ്മളെന്നാ ചെയ്യാൻ പോണത് വെക്ടർ ഫീൽഡ്സ് വർക്ക് ഡൺ സർക്കുലേഷൻ ആൻഡ് ഫ്ലക്സ്. അതിൽ വെക്ടർ ഫീൽഡ് മാത്രമേ ഇന്ന് കവർ ചെയ്യാൻ പറ്റുള്ളൂ. ബാക്കി വർക്കും സർക്കുലേഷനും ഫ്ലക്സും ഒക്കെ നമുക്ക് അടുത്ത ക്ലാസ്സുകളിലായിട്ട് കാണാം. സോ ഫസ്റ്റ് വി വിൽ ഡിഫൈൻ വാട്ട് ഈസ് മെൻ ബൈ എ വെക്ടർ ഫീൽഡ്. സോ എ വെക്ടർ ഫീൽഡ് on a domain in the plane or space. So you can have first we consider plane, vector fields in the plane. Okay, so draw the plane. So this is x-axis, this is y-axis. Suppose that this is the domain. Call it D. Is a function. So vector field is a function denoted by vector capital F, which assigns a vector f of x comma y to each point x comma y in the domain D. Okay, so this is the definition. So what is the meaning? Take an arbitrary point x comma y in D. So this is that point, and you have a vector function at that point x comma y. So f of x comma y, that is a vector something like this. So this is the value of the vector field at this point x comma y. So it will be denoted by f of x comma y. Now you take another point, let us say u comma v in the domain. So at u comma v you have another vector f of u comma v at the point u comma v, like this. So typically a vector field in the plane has the form f of x comma y equal to, so it's a vector in the plane. Input is the point x comma y in D, and output is another vector in R2 or in the plane. So it will have two coordinates. So those coordinates are functions of x and y. So it will be denoted by m of x comma y times vector I plus n of x comma y vector j so m of x comma y is the first coordinate of the vector function f, and n of x comma y is the second coordinate of the vector function f. Now in the space, a vector field look like vector f of, so x comma y comma z, so that is equal to m of x comma y comma z vector I plus n of x comma y comma z times vector j plus p of x comma y comma z vector k. In space, f is of this form. That means to each point x comma y comma z in the domain, I have a vector f of x comma y comma z at that point. So it will be something like this. This is in space x axis, y axis, z axis, and suppose that this is the domain D. This is the domain D, and at the point x comma y comma z here, you have a vector at that point in space. So this is vector f of x comma y comma z. Since this is a vector in space, it has got x coordinate. That will be a function of x, y and z. It will be denoted by m of x comma y comma z, and it has a y coordinate that will be denoted by n of x comma y comma z, and it has a z coordinate denoted by p of x comma y comma z. Okay, so this is in space. We will see examples. Sometimes these vector fields will be given by formulas. Vector field is a function. You can represent functions set sometimes by means of formulas. So we will consider the vector field, plot the vector field. Vector field. Vector field f of x comma y equal to x vector I plus y vector j. So here m of x comma y is x and n of x comma y is y. Okay, and nothing is mentioned about the domain. So if nothing is mentioned about the domain, then the domain is taken as the largest possible subset of the plane, such that this expression in the right side makes sense. Okay, so this expression makes sense for every point x comma y in the plane. So the domain is the whole plane. Domain is the whole plane, x axis, y axis. So take any point x comma y, let us say origin. So let us compute f of 0 0. What is f of 0 0? It is 0 I plus 0 j. That means the 0 vector. So at the point 0 0, I have to plot the 0 vector. But I cannot plot the 0 vector because it has no magnitude, no direction. So there is nothing at this point. Now we will compute f at some sample values. F of let us say 1 0. So where is 1 0? It is here. So what is f of 1 0? It is 1 into I plus 0 into j, right? So it is I, the vector I. So at the point 1 0, you have to plot the vector I. So what is vector I? It is this. But you have to plot this vector at the point 1 0. Remember, two vectors are equal if they have the same magnitude and the same direction. This vector is plotted at the origin, but I have to plot this vector at the point 1 0. So translate this vector, which vector? This vector, to the point 1 0 without changing its magnitude and direction. So what you will get? You will get this thing. Okay. So I don't have to draw this part. I don't have to draw this part. I have to draw this part only, because this vector I is transferred to the point 1 comma 0 without changing its magnitude and direction. So this is what I am going to get. Okay. Now you look at f of some other point. Let us say 0 1. So this is 0 I plus 1 into j. So it is j, right? So this is the point 0 1, and the vector j is like this. This is vector j starting here and ending here. I have to plot this vector at the point 0, 1. So how do I plot this vector at the point 0, 1? Translate this vector without changing its magnitude and direction. So what you will get? You will get this. Okay. Similarly, f of, let us say, minus 1 comma 0, which will be, this is the point minus 1 0. There you draw the vector. Which vector? Minus 1 into vector I plus 0 into j. It is minus I. So at this point you have to plot the vector minus I. So what I will get? What is minus I? This vector. Translate it without changing its magnitude and direction. So what you will get? This thing. Similarly, f of 0 comma minus 1, I will get minus 0 into I plus minus 1 into j. So it is minus j. This is the point 0 minus 1. At this point 0 minus 1, you have to draw the vector minus j. What is minus j? This is the vector minus j. So translate this vector to this point without changing its magnitude and direction. So you will get this thing. Okay. Now let us take another point, f of 1 comma 1. So what you will get? 1 into I plus 1 into j. So it is I plus j, vector I plus vector j. So which is the point 1 comma 1? It is here. And what is the vector I plus j? I plus j is this vector. This is the vector I plus j. Translate this vector I plus j to this point 1 comma 1 without changing its magnitude and direction. So you will get this thing. What is the magnitude here? It is root 2. This magnitude is root 2 because this vector I plus j has magnitude root 2. Okay. Similarly, at this point you have this vector of magnitude root 2. Similarly, at this point you have this vector of magnitude root 2. At this point you have this vector of magnitude root 2, like that. Okay. Now you take other points and you complete the diagram for some sample points. So what you will get? At this point it will be something like this. It will be what is the magnitude here? That must be the magnitude here also, and it must point radially outward. So it goes something like this. It is the radial vector field. It goes like this. Suppose you have a source of sound located at the origin. It produces sound. So the sound goes radially outward, but the sound is not exactly projecting like this because as distance increases, the sound intensity decreases. So the sound vector field, it will be something like this. Here it is, has more length, and if you go out it has less length. This is how sound projects. This is another vector field. This is another example of a vector field. Thank you. We will continue with other examples of vector fields in the next video.